Welcome, ladies and gentlemen, to the Technical Forum of Hydrogen and Fuel Cells Europe at the Hannover Fair 2021. Hello, dear online visitors who are live streaming here. My name is Bernd. I'm the moderator of this stage. Last time moderation for today, and I'm really happy that we can offer you lots of interesting presentations. The next presentation will be about the use case specific testing solution for the optimization of hydrogen consumption efficiency. We got the application engineer fuel cell of the AVL list here. Please welcome with me with a great applause, Bernd Krause.
Hello, good afternoon from my side. So, as announced, I'm today presenting about use case specific testing solutions for fuel efficiency. And let me go to the next slide. Oops, yes. So I'm an application engineer working for fuel cell testing technology. And today I'm focusing here on the very right pillar of AVL. It's about instrumentation and test systems. And on this slide, you see the whole range of our product portfolio. From the far left side, we are talking about actually no real hardware. It's all virtual existing. And then we go over the different application levels, integration levels, down to the far right side, up to a chassis dyno with a real vehicle. And on this overview, you see what we are now focusing regarding the use case development that we are now covering. And here you see a variety of different topics. And as you might know, there are a lot of them interdependent, so you cannot limit or separate them from each other. But today our focus will be on fuel efficiency. So the first slide as a little background for you that might not be that familiar what fuel efficiency is. Why is it important? So one aspect is legislation. So for fuel cell electric vehicles, you have the legal requirement to come up with a fuel consumption number in your prospects, and this must be certified. The second aspect is total cost of ownership, which is, for example, very relevant for heavy-duty applications. So as an easy connection, the higher the efficiency, the lower the fuel consumption will be, and the lower the costs. And the third one is the driving range. So here, the higher the efficiency, the higher the driving range. And just for some numbers about that, we are talking right now in Germany around 90 refueling stations for hydrogen, compared to more than 14,000 filling stations for fossil fuels. And also what is very important in that aspect, there is no canister available to refill hydrogen on the road. On this slide, this is just an extract out of the emissions handbook that you can download from our homepage free of charge. This is showing here how the certification is done for a fuel cell electric vehicle. This is also based on the WLTP test cycle that is shown, the driving cycle on the upper left. And usually the method is based on a gravimetric method. So you put a gas cylinder on a balance and measure at the beginning and after the end of the test cycle and building a difference, and that is your consumed fuel. But now our intention is, because as you might see from that point, when we talk about vehicles, this is at a very towards the end of the product cycle. And now the question is how to get it at an earlier stage in the development, to have here a good understanding what your final product might have regarding fuel economy. And to come to our solution, let me first point out some main areas that might impact the fuel efficiency. The first one is controls, of course. So here you can think about some operating strategies. So startup, shutdown phases are very relevant here for the consumption of hydrogen. But also, as I said at the beginning, the dependencies of other use cases, for example, degradation. So here it's just a balance between different requirements that you need to have in mind. The other aspect here is materials. The membrane is to a certain extent or a certain amount permeable for hydrogen. So this is also a fact where you lose hydrogen that cannot be used for producing the electricity. The third one is climatic. So everything what is coming from the environment, for example, cold temperatures will cause a higher consumption probably to heat up the whole system. And last but not least, the system architecture. So how your hybridization strategy, for example, is designed about fuel cell together with the battery. And this is just a schematic view of our testbed solution for fuel cell systems with the main components. And let me emphasize here two of them. At the lower left side, the Hydron, that is our own developed product, mainly used for the supply of hydrogen, but also capable of measuring in a high accuracy the consumed fuel. And on the upper right-hand side, you see here the E-library, which is thought as an add-on for our automation system called Puma. And with that together, we are able to automate all the test procedures where you can determine your fuel consumption. So with that approach, we have the chance to dig in the very early stages of the development based on systems and not already on vehicles with a highly accurate Hydron measured fuel consumption together with the E-library to automate that. And finally, let me point out another aspect regarding the Hydron-based fuel supply. On the upper part, you see how a usual test campaign could look like, where you have at the beginning of all the different test cycles that you see in the middle of the picture, which can be an FTP or a WLTP, a highway, whatever cycle. And when you base your fuel consumption determination on the gravimetric method, you need always a new gas cylinder that is placed on a balance to make here the fuel consumption measurement. And in that example, I just pointed there the test personnel forgot to exchange the gas cylinder, which ends up in the situation that you cannot run through completely the test cycle. And on the lower end, you see our approach or our suggestion, how we would see the topic here. You have an external hydrogen supply, a big tank outside of your building, and this is feeding all the different hydrons in your testbed laboratories. And from there, you are just independent of those gas cylinders that you need to exchange all the time. And it's much safer, and it will save you a lot of time. Also, what is not shown here, you can think about a 24/7 test campaign, which is not possible when you always exchange all those gas cylinders. And therefore, this is our vision how the Hydron in that regard could simplify the whole topic. So that is to summarize what we have seen before. With the fuel cell electric vehicle fuel efficiency certification, we have the opportunity with the Hydron to fulfill all the requirements based on legislation. We reduce overall R&D costs, so you have seen it before, and can step in a very early stage of the development. And yeah, this is also a kind of front-loading to come up with realistic numbers about fuel consumption. And if there are any more questions, since this is just a short, rough introduction, we are in this hall available on the booth C57. If you have any more questions, and here are the contact infos as well. And also, please save the date. In 3 weeks from now, we are also having a webinar about this topic, which takes place for a longer time, with more details also about the e-library. Thank you very much.
Thanks a lot, Bernd Krause, for this interesting presentation. If there are any questions right now, we have the chance for 1 or 2 questions. 2 minutes time left. If there's one question now. AVL, big company. So if there's no question right now, you're invited to. Oh, it's gone. It was C50.
C57.
C57, right. Okay. Thanks a lot.
Okay, welcome.